Hi everyone, here is an example of solving an equation where the pronumeral x is an index or involved in the indices, and the general strategy for these would be to take logarithms of both sides. Now there are sometimes ways you can simplify, but I can't see any easy power of 6 which would equal 15 and things like that. So let's just go straight to taking a logarithm. So I'll do a common log of both of these left and right hand side. Now using my logarithm rules, I could bring the power of x plus 1 to the front as a factor, and then I have log 15. And I could do the same here. The power of 2x minus 3 can come to the front and multiply by the log of 6. Now remember, log 15 and log 6 are just numbers. So when we, if we were to have an equation that looked like this, where it was just a number like 7 instead of log 15, we'd expand out. And we do the same thing here. We have x by log 15 plus 1 by log 15. On this side, we will have 2x multiplied by log 6 minus 3 by log 6. Now let's group together like terms. So terms that have pronumeral x, I'll put to the left. X log 15 is already there. I'll transpose this one, 2x log 6 minus 2x log 6. Now I'll transpose this, which is just a number, so it's negative log 15, and I still had minus 3 log 6. Now I'll take a factor of x, and I have log 15 minus 2, whoops, do that a little bit better, log 6 equals negative log 15 minus 3 log 6. Finally, I will divide through, so my answer is negative log 15 minus 3 log 6 all over log 15 minus 2 log 6. Now that's definitely a job for the calculator, so I'll just, where's my calculator gone? There it is. I hope you can still see that. Let's try. What have we got here? Negative log 15 minus 3 log 6 over log 15 minus 2 log 6. There's my result, 9.2331. I'll just write that down, 9.2331. In fact, I should put approximately, because I've rounded off to the 4th decimal place. Now, how will I know whether or not that answer is valid? How will I verify my result? I always like to verify. So I should be able to substitute the number 9.233 back into the original formula and check the validity of that. Now, to save typing, I'm going to store that result in memory A. So there you go, have to hit enter to have that happen. So that's now saved. I'll just clear off the screen that I've got there. Or I meant to try to do all of it, clear the whole lot. Now let's enter this expression, 15 to the power of, instead of x, I'll use the value stored in A plus 1, and I get an answer, which is a rather big number. And then I could go the right hand side, 6 to the power of 2a minus 3. And we get the same answer. In other words, the solution we found, which I stored in memory A, is the correct solution. Now there's just one other little way that we could have checked that. Let's just try this. 15 to the power of a, oh, I missed the power key, power of a plus 1. Now, I'll type it as the equation. I'll put the equals sign, and then I'll put 6 to the power of 2a minus 3. Notice that it says the answer is 1. Now that's not telling me what it evaluates to. It's telling me that the expression I just typed was true. In other words, the left and the right hand side are the same thing. If it weren't true, it would have come out as 0. So when I've entered that formula there with the equals, it's really asking the question, is this true or not? And in the case that it's true, you get a 1. Just like computers, 1 means true. And if it was false, if it was not right, that would have come out to be a 0. So you can check them in that way as well. Okay, that's enough for that one. That's just another nice little example that's going to go into the homework help series. Thanks for watching.